Here is your explanation of where the sine and cosine sum and difference of angle formulas come from. So on the left, I've drawn, well, two different angles here. Angle alpha, we'll say, is in standard position going out here. This represents really any angle, but I've drawn it in the second quadrant. And so this vertical side length, since we're talking about the unit circle, we would call sine of the angle alpha. The horizontal side length here would be cosine of the angle alpha. So this ordered pair, cosine alpha, sine alpha. We have a second angle here in quadrant 1, but this represents any second angle. This angle's beta. And right here you can see our ordered pairs cosine beta, sine beta. Out here, cosine beta, sine beta. So what you're seeing, I'm drawing a line between these 2 points, cosine alpha, sine alpha, and cosine beta, sine beta. And I'm drawing another line between those same 2 points. The second circle is, well, these same 2 rays, but rotated. So we close down angle beta to 0. And this point, cosine beta, sine beta, becomes this point 1, 0. Our point that started out with cosine alpha, sine alpha, moved along our curve and is now cosine of alpha minus beta, sine of alpha minus beta. Hopefully you figured out if this big angle's alpha and we remove angle beta, what's left is the angle alpha minus beta. So now I'm using the distance formula to just basically find the distance between our 2 points on the circle on the left, and the same distance between the same 2 points, or at least corresponding points, with the circle on the right. And hold on for a second. Well, of course, if we have actually just done a rotation, and that'd be a non-rigid transformation, this length d is the exact same length d over here, so we can say our 2 distances are equal to each other. And so if we square both sides, our distance is going to be positive, the other distance will be positive. You're just going to see a ton of algebra here. So expand cosine alpha minus beta squared, expand sine alpha minus sine of beta squared. You'll see later I made a mistake here. This should be cosine of beta. Pretty easy expansion on the right, at least a little bit easier. Cosine of alpha minus beta minus 1 squared. And, well, I didn't really write this sine minus 0. I just squared sine there. So that went a little bit quick. Let me rewind. So we're using a Pythagorean identity here, and sine squared of any angle, and alpha minus beta is an angle, plus cosine squared of the exact same angle is going to be 1. There it is. So there was already a 1 right here with our second one from our sine squared alpha minus beta plus cosine squared alpha minus beta. Now we have 2. We're looking for more Pythagorean identities on the left. There are 2 of them. There they are. And everything else just gets rewritten. Here's me noticing I made a mistake. There we go. You got it. And you'll notice everything has a 2, so we can do some nice simplification. Subtract out the 2's from both sides. There we go. And divide what's left by negative 2. And here we go. That's our first formula. Cosine of one angle minus another angle. Cosine of the first angle multiplied by cosine of the second angle plus sine of the first angle times sine of the second angle. So now what we're going to do is, instead of having alpha minus regular beta, we'll just kind of play with some algebra here. We'll replace beta with negative beta and see what happens. So what happened here? Well, we're using odd and even properties of sine and cosine. Well, cosine's an even function, so cosine of negative beta would have the exact same value as cosine of beta, so we do that. Sine is an odd function, so sine of negative beta is the same thing as negative sine of positive beta, so we make that switch out here. So now what you're going to have to realize is we're going to be, well, so sine and cosine are off by a shift of pi halves. And you'll see here in a second these things sort of change because cosine of pi halves minus an angle is going to be the same thing as sine of that angle. Sine of pi halves minus an angle would be cosine of that angle. So sine of pi halves minus alpha is cosine of alpha. And we make a switch over here. You can see I made another mistake. Pi halves minus alpha plus beta should be pi halves minus alpha minus beta. I'll fix. Here's when I figured out, I think. Yep. Oh, there I go. All right. So here is our third formula. There we go. Sine of an angle minus an angle is sine of the first angle. Cosine of the second angle minus cosine of the first angle, sine of the second angle. And then we do the same thing to get our fourth formula. Replace beta with negative beta. This is a pretty easy distribution. Cosine is again even, so cosine of negative beta is the same thing as cosine of beta. It would have the same value at least. And sine of negative beta is the same thing as a negative sine of positive beta, which is why we can find a plus sign here. Formula 1, Formula 2, Formula 3, Formula 4. Thanks for watching.